A very good day to Dr. Alvins. We are from Group 5, and today we are going to present about the Plaxis software applications, which is a review of a flow around the sheet pile. Our group consists of 6 members. They are Ahmad Izzat, Faisal, Muhammad Daniel, Noauni, Noliana, and me, Pankang Bao. Let me begin with the introductions. Plaxis is actually a versatile tool in geotechnical engineering, and they have many types of Plaxis like Plaxis Model 2, Plaxis Foundations, Plaxis LE, Plaxis 2D, Plaxis 3D, and PlusFlow. They can be applied to the footings, fields, excavations, retaining walls, slope stabilities, seep patch problems, and tunnels. And in our project, we specially emphasize on the groundwater flow around sheet piles, and we will talk about the Plaxis 2D, 3D, and the PlusFlow. Next, let's talk about the Plaxis features. Plaxis key features can be concluded into 5. The first one is the graphical geometry input. The second one is the automatic mesh generations, and followed by the high order elements, which are the productions of the mesh generations for accurate deformation and stress representations. And it also consists of the 3 advanced material models. There are mock column, hardening soil, and creep models. We can model our cases based on the suitabilities of the soil layer properties. And lastly, it is the visualized output. So this is the image that enables us to have a better graphical view of the geometry properties and for the better understandings on the geometry informations directly from the image. And next is followed by the automatic mesh generations, and they are the high order elements. The modeling will be divided into like the triangular shapes. These are the so-called mesh generations and high order elements so that it is easier for the numerical analysis in Plaxis software. Lastly, it is the visualize the output via the Plaxis output software. So we can see our result based on the different conditions and different visualized methods. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Izzat Putra Musliman, and I'll be explaining to you what is the advantage of using Plaxis in geotechnical application. So the first advantage is Plaxis is a very useful toolbox which is used by scientists and engineers to deal with complicated issues regarding with geotechnical application. The second one is it has a user-friendly interface which is very good for us who does not have the first-hand experience using the software. The third one is it helps us engineers to see how structures or building behave according to different geotechnical behavior. The fourth advantage is Plaxis help us to view things in 3D view, which help us to understand how structures and ground move. And the fourth advantage is that Plaxis can show how well does a structure hold out during an earthquake, and this information is very valuable since designer and engineers can help build a better building which is strong and safe.
My name is Nolana and I will continue to present about the limitation of Plaxis software in geotechnical applications. The first one is cost factors. Plaxis can be relatively expensive, particularly when compared to some general purpose of software options. The higher cost may pose challenges, especially for small project or individuals seeking license. And the next one is learning curve challenge. Mastery of Plaxis demands more effort compared to simpler software alternatives. The steeper learning curve can act as a barrier, particularly for beginners entering the realm of geotechnical software. The third one is the material model limitations. While Plaxis offer a range of soil models, there might be instances where specific models needed for a particular project are not included. This limitation could require users to find workaround or make compromises in their modeling process. And the last one is the opaque learning workings. Software's internal workings are inherently unclear, making troubleshooting and customization difficult. This obviously makes troubleshooting and customization challenging for users who desire a deeper understanding or require a high level of customization in their analysis.
Assalamualaikum, my name is Muhammad Daniel Izwan. and I will continue the presentation for case study. This case study based on soil assessment and use Plaxis 2D software for modeling. First, we need to set the safety criterion at 1.5 meter for retaining wall stability. Then derive soil parameter from tests including corrected blow value. Create a shapefile model with a specific dimension and fixities. The simulated groundwater at riverbed elevation. From the standard penetration test result, drilling show clay sit up to 20 meters deep. Then we need to process soil data include unit weight of 18 kilonewton per meter cube, shear angle of 30 degrees, and modulus of elasticity 800 kilonewton per meter square. So for the next slide, Plaxis shapefile calculation involves 3 phases. And it starts with calculate the lateral coefficient value of the soil at rest without considering the shapefile material. Next, activate the shapefile in modeling using the plastic calculation type. And the last one is utilize the phi calculation type. So in Plaxis 2D modeling with a 7 meter deep corrugated shapefile, the ultimate moment on the shapefile area is found to be 254.72 kilonewton meter. So next, based on the result from case study, the concrete shear strength exceed the Plaxis shear force and ensuring the corrugated shapefile security against the shear force. Plaxis 2D calculation for 7 meter deep corrugated shapefile show a stability factor of 2.98, and it is surpassed the safety factor, which is 1.5 meter, and ensuring a secure stability level from the corrugated shapefile. So this figure show the maximum displacement are less than 10 cm in the landfill area and under 5 cm where existing soil meets the embankment. That's all from me. Thank you.
Assalamualaikum. A very good evening to my lecturer, Dr. Alvin, and my fellow classmates. Today, my name is Faizal bin Tarini. Today, I'm going to present about the case study for our sheet pile wall. Today, I will go into the fascinating world of sheet pile wall design, focusing on 3 key approaches. First, earth pressure theory. Second, finite elements method and of Plaxis and OptimG2, and the last one is the innovative of GSK model. Let's start with the earth pressure theory, a design method commonly used in Denmark, and this is a process stood the test of time, proving its significance in the structural integrity of sheet piles walls. Moving on to finite elements method, implemented through tools like Plaxis and OptimG2, offer significant benefit in stimulating complex soil conditions. This method allows us to evaluate crucial parameters like anchor forces and bending moments with precision. Now let's introduce the GSK model. This innovative approach serves as an alternative to the conventional monocolumn model. Considering stress-dependent friction angles, the model parameters are determined through rigorous structural testing, ensuring accuracy in our design. For the second slide, as we analyze the result, notice the lowermost curve representing IRD R equal to 0.20 value and the uppermost IRDR with values is equal to 1.20. We compare this with Alton equation, observing differences in friction angles at different stress levels. Last but not least, our study reveals interesting insight. In the non-associated case, we found strong agreement between finite element programs. However, in the associated case, deviation of approximately 20% were observed in maximum bending moment. The Brinch-Hansen method generally aligns with optimum value, while the GSK model produces smaller results due to lower stress level. In conclusion, we journeyed through the foundation of earth pressure theory, the advantages of finite element method and the promising possibility presented by the GSK model. This approach played a pivotal role in shaping the future sheet pile wall design. Thank you, that's all from me.
So this is the recommendation for using Plaxis 2D software to see the flow around a sheet pile. So we can utilize the available tutorials and manuals such as Plaxis 2D version 20 or flow around a sheet pile walls to gain a comprehensive understanding of setting up the analysis, creating the geometry, and defining material parameter which analyze the flow field. So we can do more recommendation by using a research paper, which is design of encouraged sheet pile using Plaxis 2D or comparison of conventional method with finite element analysis using Plaxis 2D to understand a real application and the behavior of sheet pile while analyzing using Plaxis software. So for the materials, we can consider the material database available for sheet pile walls in bending, which can provide valuable insight into the parameters and assumption for modeling sheet pile walls in Plaxis. So all of these are resources. The user can gain the necessary knowledge and guidance to effectively utilize Plaxis for analyzing flow around sheet pile in geotechnical engineering. So, in conclusion, Plaxis software is a suitable tool for geotechnical engineers and researchers for analyzing flow around sheet pile walls. So, by leveraging the available resources, users can gain the necessary knowledge and guidance to effectively utilize the Plaxis software for the specific geotechnical analysis needed.